Uh, yeah, we are live now. And good morning, good evening, good afternoon, everyone from wherever you're tuning in. My name is Prithviraj and I am your host for the evening. A very warm welcome to you all to the Chaos Engineering Meetup. We host monthly meetups and this is the August edition and we have some exciting content on your way. So before any further ado, I would like to share my screen with the detailed agenda for the evening. And it's evening out here. So if you can see my screen, as you know that this Chaos Engineering Meetup is organized monthly by the LitmusChaos community, and it's part of the CNCF Chaos Engineering Meetup group. And today we have amazing couple of agenda items for you. We have Shubham Chaudhary, who's again joining in from Harness. He's a senior software engineer at Harness. He'll be talking about how you can create your own chaos experiments using the LitmusChaos SDK. So there's a lot of chatter about creating custom experiments and how you can bring your own experiments if you're using Litmus. So Shubham will be talking about creating your own experiments, and Akash, who is been one of the pioneers in creating the HTTP chaos experiments, he'll be talking about how you can run HTTP chaos and everything related to the HTTP chaos experiments. So before I hand over the stage to both our speakers for today, I would just like to introduce you to LitmusChaos a little. And there are a lot of folks who are new. If you want, you can just introduce yourself in chat. And I'll also be sharing some good amount of resources in chat so that, post this meetup, you can just go on and go through the resources. And don't forget to join the LitmusChaos Slack channel. That is where all the conversation happens. So even after this meetup, what you can do is you can be a part of the Slack community. You can ask your questions because chaos engineering is a topic which is new for a lot of people. So you can just be a part of the Slack community, ask your questions, get help, understand from the community members, and be a part of more community activities such as meetups and community sync up calls that happen every month. And of course, your contributions will be rewarded. So all those who are contributing back to the community in form of technical or non-technical contributions, be assured that you will be receiving some swags from our end, from the LitmusChaos community itself. So just a quick intro to Litmus. LitmusChaos, as you know, is a dynamic open source chaos engineering project platform, and it's used to induce chaos in a controlled way in your systems. Chaos engineering, as you know, I mean, in layman's terms, is basically inducing a fault deliberately into a system into your system to identify chaotic conditions or production failures or vulnerabilities that can usually happen when your system goes out in production, and which can possibly bring your system down. So that's just an intro to chaos. If you don't know what chaos engineering exactly is, I'll be sharing some resources while Shubham and Akash deliver their talk. And stay tuned, folks. Once again, thanks a lot for joining in. And without any further ado, I would like to hand over the stage to Shubham, who can take it forward.
Yeah, thanks, Prithvi. Hi, good evening, everybody. Hi, I am Shubham Chaudhary, one of the contributor to the Litmus. I'm sharing my screen. Yeah, so today I'm going to discuss about the Litmus SDK, which will help us to build our own custom chaos experiment in which follow our BYOC, bring your own chaos model. So in Litmus, we have a three SDKs. One is Go SDK, where you can generate your Go experiments. Another one is Ansible SDK, where you can generate an Ansible experiment. And third one is a Python SDK, where you can generate a Python experiment. So as part of this talk, I will cover the Go SDK part. So you can so for the for the reference, you can use this README, which is available in Litmus Go repository inside the contribute/developer guide. And I also wrote a blog for this. I mean, you can also follow this blog. So I'm just going through the README to explain, I mean, what it is doing, and then we will, then I will go for the demo part. So as part of the experiment generation, we generate the chaos experiments with some default steady state checks. We are generating a chaos result in the pre and the post experiment injection. And apart from that, we are running the probes for the SLO validations in the start of the test, in the continuous manner, and the on chaos mode, and also in the end of the test. And also for this one, for the SDK generation, we are generating a default chaos lib, so which can be generated in a two-way. One is exec base helper. So in exec base, you can provide some chaos kill command and chaos inject command, which will be and you will provide your application details. So it will run those command inside the your application, target application, and it will run that. So this is for the template part. This is just for illustration, but you can change that chaos lib to based on your use case. You can just write your own chaos lib and you can run that experiment. And the another chaos lib way is helper based model. So in helper based model, it will launch a helper pod with all the helper pod configuration along with the helper image, where you can create your own helper image with that chaos lib, and you can run inside a helper pod. So and also, apart from the experiment generation, it also generates the experiment metadata. It's CSV file, it's experiment chart, basically the experiment CR and the engine CR and all the RBAC required for it. So we will see while we are demoing. So for the Go, there are some, they mentioned some prerequisite. The Go should be there. You need to clone the repo, that Litmus Go repo. Then inside the contribute/developer guide, you can go to that particular folder. And inside there is a you can build your own binary based on your like architecture. And then here you have a attribute.yml. There is a attribute.yml.sample file. With that, you can create your attribute.yml and you can tune all the values here. So here I will go through all the values here. For example, name, the version, or this is the category. For example, we have a generic category, or if it is related to some application like Cassandra or Kafka, you can like use category accordingly. And this is the repository link. This is our Slack link. It is the description. And if you want, this is for the this is for the metadata. We have a Chaos Hub where we have all the Chaos experiment listed. So for that part, you need, if you want to, search it by the keyword, so you can place keywords here. It is the platform which it supports. It is the scope, whether it is a namespace scope or it is a cluster scope. Next one is auxiliary application checks. If there is any dependent applications and you want to check the status of those applications in pre and post chaos, if they are affected by the chaos or not, then you can make it true. And these are the RBAC permission which is required for that experiment. And this is the maturity, and here you can provide your maintainer detail, which will be displayed inside the Chaos Hub. Here the provider and some references you can provide. Yeah. So after you have you generated the Litmus SDK binary, so there is a generate command. So inside a generate command, there is a generate type. So generate type can be of two types. One is experiment. So if you want to generate experiments, then you can use experiment. In experiment, we have a -t sub command where -t will be the type of helper we want to use, the chaos lib. One is exec model, another one is helper. I already discussed these two things. Then if you want to generate the chart, in chart we have a two type. So the chart will generate all the metadata and CSV file which we will place in the chaos chart repo, and based on that data, it will render into the Chaos Hub. And here it is the category detail and the experiment, the chaos engine, chaos experiment, the RBAC detail, and other things. So here we displayed that of like what all the file will be created in which places. After that, here we explained about all the what subsection is that experiment will contain. I will go through that whenever I will generate it. So for the testing thing, either you can use Octeto. So Octeto will help us to create that environment. You can directly apply the YAML inside it, or you can create the chaos engine and chaos experiment the way we are doing with the Litmus 1.0 mode. So there you can create directly chaos engine and chaos experiment. The another way is if you have generated the metadata, then you can and you have uploaded to the Chaos Hub, then you can use the Chaos Center, the Litmus 2.0 to run those experiments. Okay, so I will just go through the, I'm just going to the coding, the demo part. So here you can see inside the contribute developer guide, we have a Litmus SDK and all the files here. So I'm just going to the terminal. Yeah. So we can go to the contribute developer guide here. So here we can build our own binary here. So I have generated my own binary. I can provide its permission. Then for the first part, I'm generating an experiment. So we will use generate, then experiment. And for this type, I'm choosing the helper type for the chaos lib, and here the attribute.yml.sample file. So I will just show you the attribute.yml.sample file as well. So this is the same file where we are providing all the tunables for the experiment. So based on your experiment, you can change it. I'm just using the default attribute.yml.sample to generate my experiment. So the experiment is created successfully. So if we will go to the experiments part, so as part of the experiment generation, we are our category was sample category, and inside this is the sample exit chaos experiment. So here you can see this is our experiment, and here we are creating the chaos result in the pre-chaos, and apart from that we are some logging some data, and after that we are just performing some steady state checks. We are checking the uh, application under test status, and if you have any other study state check, if you want to validate anything before injection of the chaos, you can add your cases here. Then apart from that, we are running the probe here for the start of the test in continuous mode here, and here we are calling the corresponding chaos lib. So for this, I just bootstrap my that sample chaos lib. If you want to use your own chaos lib, you can call your chaos lib here. Then after the experiment is done, the chaos is done, we are doing the steady state check in the end of the experiment as well. So this is, we are generating steady state, we are checking the steady state in the end, and again we are running the probe, and in the end we are running we are just again updating all the report to the chaos result, and we are generating the result events also inside the chaos engine and chaos result. So apart from this, as part of this generation, we are inside the package, we are creating the types.go for this, where we have all the structure and all the attribute we needed for this experiment. So for this experiment, for the say sample experiment, I need all these attribute. If you need any attribute, you can add here. And as we are running this as a Kubernetes pod, so we are setting those attributes as an environment variable. So you can add the environment variable here. So apart from this, we are generating a chaos lib inside the Litmus lib. So here you will find a sample exit chaos, and here it is a helper model. So here first we are deriving all the experiment related information. For example, the target application where we want to inject the chaos. So we are deriving all the target application, and then after that we are running our own chaos probe, which will run for the chaos duration only. And after that, for the each pod, we are launching the helper pod, and we are waiting until the helper pod is completed, and we are validating whether the helper pod is failed or passed. So accordingly, we are patching the verdict for the experiment, and when the helper pod is completed, so we are deleting it. And for if you will go to the helper pod, because this is for just for illustration. So here inside the command, I'm just writing my own command, like I'm just echoing this is a sample pod, and I'm just sleeping for 10 seconds. You can replace your helper pod based on that. So as we are done with the experiment is generated. So to run this experiment and to build the image, we need to make a changes into bin experiment.go file as well. So here we need to import that experiment, and we need to add a match here. So I have already written that. I'm just uncommenting that part. So after we are done with this, then we can directly build the image for this. So here you can write your own repo name and your image, and you can build. So I have already built the image. So I will use my own image to run this experiment. But yeah, you can build your image and you can put inside the chart. So now I'm just going to generate the charts for this experiment, the experiment CR, engine CR, and all the metadata. So the chart is also created. So here inside the experiment, you will find the chart. So here this is a engine.yml where we have like where we are configuring the application details and the auxiliary application details, the service account, job cleanup policy, and the experiment detail. So here I have provided the I'm using all the default values. So for my case, I have created the Nginx application with the matching labels in the default namespace. I'm going to use the same values, whatever is generated by default. And inside the experiment CR, you can provide your own image here, like whatever you are generating. So for I have generated my own image earlier, so I'm using the same image here, and you can provide all the tunables here. So I'm just using all the default values for this experiment. And inside the RBAC, if you have any additional RBAC, you can update the RBAC here. But for me, it is enough. And this is the CSV file which will help us to render inside the Chaos Hub. So it contains all the metadata related to experiment. Okay, so now I'm going to create the Chaos experiment engine and RBAC, all these data. So before going to, I will you can see that that Nginx application is already running in default namespace. Also, I have that Chaos operator is also there. You can see the Chaos operator is already running in Litmus namespace, this Shubham namespace.
When can we ask questions? Is it end or like can we ask now?
Yeah, I mean, you can ask. Yeah.
Okay. This is Ram. So this is the first time I have joined, right? So a couple of questions I have. So one, you have a target system where you wanted to go ahead and then run the Chaos experiment on, right? I think which is what I think you're talking about Nginx as a target system. Am I right?
Yeah, target.
Okay. Yeah. So then you're trying to go ahead and then get a pod or an image created and then deploy in a pod as a Chaos engine, is it?
So Chaos engine is basically let me open a Chaos engine again. So if you see this Chaos engine, right? Mm-hmm. So here, this is a custom resource definition, CR, basically CR, where we are providing the application details and all the tunables. After this, we are launching an experiment pod, yeah, where we are performing all these steps, whose image we are building.
Okay, and this is primarily not a target system, right? This is primarily a Chaos engine, right? You are building, right? This pod will actually go and talk to the actual target system and then do all those experiments. Is it
correct? Yes.
Okay. Thank you.
Hello Shubham, I'm audible.
Yes.
Hi Shubham, Sama this side. So I just have a question regarding two parts. So first is that you created an experiment and then you created a chart. So is it the sequence that we need to follow, or it's either or kind of a situation that we can either create an experiment or a chart? So for example, you were saying that we need to, if you go to the experiment.yaml file for this one and the chart that you generated, so you were providing an image there. So that is the image that we would be that would be having our custom logic for the Chaos experiment.
Yes. Yeah, I mean, you can generate in any way, but yeah, because we need that image, this image, which should contain that our custom experiment binaries. So that's why we need we are generating the chart after this.
So
but there is no dependencies.
Okay, so just one clarity. So in order to put our custom Chaos in this Go runner image, so we need to first create an experiment, or like how do we go about that part?
Yeah, so first we will create our experiment. Then after the experiment is created, we will build the image.
Okay, and then we will create a chart for that.
Chart.
Like chart. Okay, so I think this is part of the step. So I thought that it would be like it can be created either experiment or a chart. So I think so. First, we have to create an experiment just for my clarity. So first, we'll create an experiment, then we'll build an image, and then we'll create a chart where we would reference that image.
Correct. Chart is just a way to run the experiments.
Okay, okay, got it. Thank you.
Yeah. Okay. Like, do we have any other question, or we can go with the demo? Okay, I think I can go with the demo then.
If it is a different library, then we have to use some different. The procedure is different. If it is not Go library.
Yeah. So I already mentioned it in the beginning that for Ansible we have a different SDK, and Python we have different SDK, and Go we have this one. If this is another language, right, apart from these three,
Yeah, but
then
see, I have a K8 environment. I want to do some experiment, so I can do in any language. But the only the procedure different, or the way of running also different.
I think way of running is same. Only the process is different.
Okay, so means at the end it does the same thing. You mean to say?
Yeah, the experiment generation part is different. If you see all these chart, right, Chaos Engine and Chaos Experiment, and these chart are same for all languages.
Okay.
So sorry to interrupt again. So one more question, some of this side. So when we are creating the experiment and making the changes to the Go file and building the image, so would this SDK take care of updating the Go mod files as well? Go mod, Go sum files? Or do we
Yeah.
need to...
So I mean, it will import all the, like, whatever by default it will import all the packages, whatever it is required. But yeah, because those packages will be new, then you need to do Go mod tidy by yourself.
Okay, I think so that would be done in addition to
Yeah, because for this sample experiment, nothing new is required. I mean, it is using the same packages which is used by other experiments, so that's why I did not need to do Go mod tidy.
Okay, got it. Thank you.
Okay, so if okay, I think, yeah. I need to check if I have generated the chart already or not. Experiments. Yeah, it is. Okay. So now what we can do is we can create all these RBAC and charts. So let me do that. RBAC engine. So we can see all are created now, and here also you can see the experiment pod is started, right? So we can wait for some time. It will launch a helper pod. Yeah, so here you can see helper pod is created. So like, this is a sample pod where we are just echoing something, so we can just confirm the logs. So you can see like, we are just writing this is a sample pod and it is completed immediately. So now I can log the experiment, our main experiment. So here you can see in the beginning we are logging about we are creating the chaos result. After that we are verifying the application under test status, our steady state checks. After that we are because here there is no probe, so we are not running any probe. After that we are launching our helper pod. I mean, we are first driving the application. You can see this is a target pod. We are driving the target pod information. After that we are launching our helper pod. We are waiting for the chaos duration, and After that, we are validating the helper pod status, and then we are deleting the helper pod. You can see the helper pod is already deleted. And after that, we are updating the chaos result. And because here job cleaner policy was set to delete, so it deleted all the experiment pod and the runner pod as well. So as the experiment is completed, it is also generating the chaos result. So we can verify the chaos result as well. So you can see because this is an older chaos result that was created earlier, so you can that's why we are seeing two events, to pass and fail, because one was earlier 1 hour ago. So here you can see awaited event and pass events, and here you can see the basically the targeted pod name, its kind, and its status. And here you can see the history of the number of pass experiment, fail experiment, stopped, and here you can see the experiment, its phase, its verdict. If there is a probe, then probe success percentage, and if it is failed, then fail step, and all the details. And also we are keep updating the chaos engine for all the details. You can also describe chaos engine. So here we are generating the events at different step of the experiments, and apart from that, we are also updating the status and everything here as well. Yeah. So this is this is all about the Litmus SDK. So I will share that README and blog details in the chat.
Okay,
Sure.
so how many pods it created and deleted? What are the pods it created and deleted? Can you repeat that?
Which one?
Yeah,
This
instead of let's say I have one pod of target is Nginx, but while you run, what are the pods it created and then deleted? One is
Okay.
helper.
One is experiment.
So 2 pods.
Yeah, for the experiment execution, it is for the execution part, it need 2 pods. Yeah.
So helpers, what is the function of helper and what is the function of?
So yeah, so helper is an optional thing. Like for example, in this case, we need a helper. That's why this is a helper model. There is also, I mentioned it, exec model as well. So helper is required if you need some some privileged permissions, or some if you need to bound some you need to mount some volumes, for example the Docker sock. For example, if you want to kill a container, then in that case you need to mount the socket path. So in those cases you need a helper, or if you need to perform some step where you need a privilege permission, right? Or
Yeah, so where will get the documentation? Can you show that we can read that in more detail?
for the SDK, I'm sharing in the chat.
So Litmus SDK
Guys,
is kept.
a quick question around the helper parts, probably not related to SDK. One of the kind of asks that we have is, how can we specify like CPU memory request and limits, liveness readiness probe, because those are kind of standards as part of our Kubernetes cluster deployment. And currently these parts are created dynamically. So is there a way to kind of specify those kind of configuration through workflow YAML or through other means, so that our requirements are met?
Yes, yeah. So the resource requirement we already have inside the Chaos engine. We can provide the resource requirement for all, like whether it is helper pod, it is experiment pod. For even our control plane also, you can provide all the resource requirement, right? For your second question is liveness thing. So for the liveness directly inside the helper, we do not have any right now. We are not providing, but indirectly you can have. For example, we have a probe for SLO validations. So if you can tune the probe in such a way that if those SLO, like for example, if some specific application is not running right, if it is down for some time, then it will automatically abort it or something. We can control it by the using the probe.
But the probes are for this helper part itself, right? Maybe I write some command exec, whatever, right? It doesn't need to be an HTTP probe. It could be some other probe. But the question I'm thinking is, what is there some other probe? How do I see that? Even if I want to fake it, what should I fake it?
I mean, I did not get your question completely, but can you repeat?
I think Shubham, what Raj is trying to, so maybe correct me if I'm wrong. So is it possible to set liveliness and readiness probe on the helper pod so that maybe I think there might be some policies in a cluster which does not permit a pod to get created if there's no configuration like liveliness or readiness probe on it. So in this case, because since it's not a configurable thing, the helper pod configuration, so is it possible to explicitly change the manifest file externally of the helper pod to have liveliness and readiness probe part of it?
Understood. Yeah.
That's the question. Exactly.
Correct. Yeah. So I think, so we do not have any, like right now, we do not have any option to configure that liveness and readiness probe directly, but I suggest a way using probe indirectly, but directly we do not have. I think we can have this.
And I think one more point that is worth considering is that to have a volume mount support for helper pod, because I think that was a requirement I raised. I'm not sure if it's already part of the helper pod or not, but I think there are situations where we want to mount external config file or data to the helper pod so that it's a requirement for the logic to work. So as of now, it does not support the mount. So maybe
I would recommend go all the way, right? Instead of doing this piecemeal, try to support like whatever the Kubernetes part specification supports, right? You should be able to support it in some sort of a configuration way, because tomorrow I may need something, someone needs something else, right? So you provide that flexibility and you fix this in one go, and that would be helpful. And then it makes your life also easy.
Okay, I understand your point. Actually, the helper pod have a support for the volume mounts right now, but those are the fixed volume mounts because the code which is running inside each helper pod is fixed. It is our own code, so we know what data it is required now. So accordingly, we are mounting the volume. But we can think of it if we can provide a support for the dynamic volume mounts. But we did not see any use case where because the code whichever is running inside a helper pod is fixed. It is not dynamic. So if we are changing a code and inside a helper pod for specific helper pod, and for that we need some volume mount or anything, then we can update the experiment accordingly, that particular experiment.
Yeah, and I think same goes for the pro pod as well, because pro is something that
pro pod we have now we have a support for providing everything, including the volume mounts or everything we have.
And is it from which release? Do you have the support?
It's I think it's from 2.11.
Can you show the docs?
Docs. I will share the docs link here.
So just one question before like you go ahead.
No,
to
if
the
you
docs,
show it, then it is good one. You share a letter, we don't know which point you are talking.
Okay.
Shum, just one question just before moving to the docs part. So in the experiment, you were showing that you mentioned the args explicitly that it was printing just a single line message when you were creating the experiment. So in the create pod section of the experiment, you mentioned the command that the helper pod would be running. So can it be overridden during runtime, or is it something that is fixed and hard coded as per the experiment only? Or like, I mean, do we have certain kind of flexibility to override that command as well?
So that sample exec chaos experiment with the helper is just for illustration. It is a sample, so that's why I hard coded. But if you are generating, you can override it, or however you want, you can modify it accordingly.
So do we have an option, like just for my clarity, do we have this option in the like chaos experiment or chaos engine file to override the command for the helper pod? Like what would be executed? I'm not sure if my question is clear.
Yeah, I mean, I understood your question, but I did not able to understand the use case, because the helper pod, whatever the helper is running, right? So whatever command it is required, or like
So I think
anything, it is
if I understood
fixed.
correctly, the helper pod, so in the helper pod, the experiment that we are designed would only be for a specific purpose, and that would be the only command that would be running. So we like, I mean, the flexibility is not required at that part. So just,
Yeah.
is it what you were trying to say?
Yeah, for each experiment, there is a different
Okay.
helper. For example,
Okay.
what helper for container kill is doing, the network chaos will do different thing, right? So for each helper, different thing is there.
And the experiment would, the custom experiment would be part of the Go runner image only, or can we have a different image too?
Yeah, you can, for the helper, if you are using helper model, then inside a helper, you can run any image. I mean, you can write in any language and you can build the image and you can use inside the helper.
Okay, and all the pre-checks are not part of the helper pod. The pre-chaos checks, that only the chaos injection is being taken care by the helper pod.
Correct.
Okay, so in that case, it would anyhow work because all the rest of the logic is out of that helper pod.
Yes.
Okay, thank you. Got it.
I think
I have one more ask real quick. By the way, you're doing great here. I mean, Shubham, yourself, Nilanjan, Prudvi team. I mean, this is awesome. What you're doing here with the HTTP experiments also. It is a great asset to the tool. So my ask is, currently you have a very nice like logging, but other day I was trying to troubleshoot an issue. I felt like adding additional, trace logging or something like that would be helpful. I mean, think on those lines. I don't know if anyone requested, but if you could add additional trace logging, that could be enabled with some flag or something like that, that will produce more logging. That would be helpful. That's what I felt. Thank you.
Yeah, that's a good point. I mean, we are also planning for this. I mean, some stack trace kind of thing. Yeah, I mean, we are already planning. So yeah, that's a good point to raise. Yeah.
Yeah, great. Thank you.
I think
Again,
there
you
is
guys are
also
doing
one
awesome,
talk.
guys.
Yeah, thanks. So as like there is also one talk, so we are running out of time. So I think Akash can start.
Thanks a lot, everyone, for your questions once again, and maybe you can ask them in chat. If we have time in the end, we can cover them, or else, as I mentioned, once again, you can join the Litmus community, the Litmus channel, and the Kubernetes Slack, and ask your questions. And with this, I would invite Akash on stage to talk about HTTP chaos with LitmusChaos.
Thank you, Prithvi. So, hi everyone. It was a great demo by Shubham on the Chaos SDK, Litmus SDK. Now let's move on to talk about HTTP Chaos, which is the new set of experiment that have been added to the Litmus framework. So currently let's just start off with how HTTP Chaos actually works. So this is a scenario before the chaos has been injected, and how what happens in that scenario is that service A, which can be a user or any service that is calling service B. Right, so service A sends a request to service B, and it is routed to the port on which service B is accessible at pod side, right? So this is where the chaos is not injected. But when we inject the HTTP chaos, what we do is we first of all change the routing. So what happens is basically we forward the incoming request, whichever is incoming, to port 80 for service B. We forward it to the HTTP chaos pod which is running there, and there we can actually do the request response modification, which helps us to make HTTP chaos happen. So this is a scenario where when the HTTP chaos is injected, this is how the request is routed through, right? Now, so this is like a very simple explanation of how we are doing it internally. it requires two things that needs to be changed inside the pod. One is changing the IP table the rule sets, which basically creating a new rule set to forward the request for the specific service to the proxy port that we are running, right? Okay, so this is like a very simple example. I will not go into a very deeper section of how we are doing it, but this I guess explains a bit of it. Now let's talk about the experiments that are right now available in HTTP kiosk category. So first we have the HTTP latency one, which is basically it adds latency to HTTP request by adding a sleep timer before like forwarding request to the server. So it can be used to like simulate delayed responses from the APIs that we are using, and we can tune it using a latency variable. Moving ahead, we have the HTTP reset peer, which basically simulates a TCP connection reset error, and it does it by basically closing the connection after specified timeout. So that timeout can be provided as a variable called reset timeout. So we can use it to connect connection failures where the API is not accessible or something like that, right? Now the one with the where we can actually do modifications inside the request. So first is the modify status code. So this experiment basically what it does, it basically helps you to like modify the status code to any value you want to, and after you do that, then the incoming request will have that specific error status code with it, right? Also, it has another environment variable called modify response body. So what it does, it basically also changes the response body to a specified template according to the response code. So it is like you can set it to true to do that, or you can set it to false to have whatever error you have. So we'll see that in the demo, it will be more clear in that. Then we have the HTTP modify body. So currently what we can do with HTTP modify body, we can override the complete body to something new. So supposedly if we want to give some other kind of response to the API, or do like give some incorrect or invalid response, right? Which our like the service which is accessing the API would not be able to get properly. So this kind of chaos we can do it using HTTP modify body. So we can tune the response body content using response body variable. But right now we can only overwrite it. We cannot fine tune our like according to a regex value or something. Now the HTTP modify header is basically used to modify the headers. So we can add an header, or we can modify any existing header as well as we can remove headers. So for removing headers right now, what we can do is we can provide the key and then provide an empty string value. It does not actually remove the key from the headers, but it does set it to, you can set it to an empty value to simulate like removal of the header. I have some. Okay. Yeah. I just want to confirm, like I'm audible properly. Like my voice is.
Yes, Akash, you are audible.
Okay. Yeah. Thank you. So yeah. So with a modify header, we have another option called header mode, which basically helps you to set which header you want to modify, the request or response header. So if you set it to request, then the incoming request coming to service B, the header with that request will be modified. And if you set it to response, the header with the response, like whatever the service B is sending a response, all the headers in that will be modified. So you can set it using the header mode, and you can use the header maps variable to do something like that. So I'll just move ahead to talk about a few important variables that are there, which these are common to every HTTP chaos experiment. First is toxicity. So this is toxicity is available in the latest release of Litmus. So with toxicity, what you can do is you can provide a specific percentage, and that percentage will define the probability of any request getting affected. So supposedly if you provide the value to be 50%, then there's a 50-50 chance of a request getting affected by the specific chaos you are doing. So it does not directly mean that every alternate request will be affected, but it does mean that there's a probability of 50-50 for each request to be affected. When you talk about in large request sense, this basically comes out to be a 50%, like 50% request getting affected. So second is the target service port. So this is the service port you have to provide for on which you have to inject the HTTP chaos. So this is the port at the pod level thing. So this is not the service port, right? So suppose I have Nginx pod running running at the container port 80, right? 8080, and I have created a service which is exposing that Nginx pod at port 80, right? So I will provide the values 8080 because this experiment executed inside the pod, not inside the not at the service level, right? So this is how we need to provide the target service port. Another is the proxy port. So this is at which the request will be routed through to do the modifications of the request and responses. So it is by default set to a 20,000 port value, which is in most of the scenarios an empty a port which is not binded to anything. But if you have something binded, or if you want to provide a specific proxy port to be used, you can use this variable environment variable to do that, right? So yeah, so this is the basic informations of HTTP chaos. Let's just move ahead. So I'll just show you how we can define the variable. So like this is how we define the latency variable. It is basically divided in milliseconds. So 20,000 means like 2 seconds delay will be there. You can provide a millisecond value there. With reset here, we have the reset timeout environment variable, and this is also in millisecond. So you can provide it. With HTTP status code, we have the status code variable where you can provide it. So currently, these are the supported status code that are supported. If you provide any other status code, it will basically throw out an error. So you'll have to use any of the status code present in this list here. One more thing you can do is you can provide multiple status code as well. So I can here provide status code, supposedly 400, 401, 404 as well from the list. And the experiment will select any one of that status code and use it in the one. So you can do a randomization of it when you are doing multiple experiment runs, but this will be done at like one single experiment run level, not at the request affected level. Like every request will be affected by that one selected, and every iteration of the experiment also will be affected by one status code. So that is the support for right now. And the second thing is the modify response body. So you need to provide a true or false value depending on that. So we'll be seeing a demo of HTTP chaos moving forward. So with the HTTP modify headers one, you can provide the headers as a map value like this. So is like you have to provide this with the double code so that it can be passed properly. You can provide a header, or even you can provide any header that is already present here, the value for the key for it, and then provide a value for it. It will be overridden by that one. And then we have the header map variable, which basically defines whether you want a response or in a request mode. So you can provide it here. With the body, we have the response body, which basically will override anything. So you can provide an HTML content here. You can provide a JSON object here as well. Anything you provide will basically override the body at that. Right. So yeah. So this is about the intro for it. You can post we can go to questions after the end of demo. I guess it will be better. Or you can put it in the charts and I will take it after the demo. Right. So okay. So this is the basic introduction to HTTP chaos and what all HTTP chaos and Litmus is offering currently, all kinds of experiments and how it is actually being injected internally. So now let's move ahead and actually see it in action. So what I have here running is a very simple Nginx application, and I have I have put it up as a service, and I have external IP here. So when I try to access the service, I can see the service being accessible with this body, and I can see a status code of 200, right? So the current demo I'll be doing is for the HTTP chaos. So what we are expecting is that once we inject the experiment, we will be able to see this status code modified to what we have provided, and also this body, because we will be providing the modified response body is true. So this body will be changed to a predefined template, which is nothing but just basically a very simple HTML content to show that the specific error code. So it will be changed to that as well. So this is the expectation for the experiment, right? So let's move ahead and do it. So I have the Litmus chaos center running here. So we will get to chaos scenario and schedule a new chaos scenario section, selecting a self agent, moving ahead, selecting some Litmus chaos. So that So HTTP latency is available from 2.11, and all the other experiments are available from 2.12 of Litmus version. Sorry, HTTP latency is available from 2.10, and all the other experiments are available from 2.11. So if you and the toxicity is available, support is available from 2.12. So yeah. So I am running right now 2.12, so I have all the latest things available, and the Chaos app is also sorry. So moving ahead, just get to add an experiment. So I'll just select HTTP status code experiment here, and let's edit it. Yeah. So I have the Nginx application running here. I won't provide any probes here. So there is no state like default, like there's no status check for this experiment. So the experiment would pass, but we'll be seeing the affect, like the request getting affected through postman service request. So moving us through. So we only have one iteration, and so I'll just provide 500 as the status code, which basically will give me a 500 internal as status code. I'll put the modify response body as 2. So this target service port. So my application engine application here is running at service port internally as like at the port level as well, and I export the service as port 80 as well. If this application was running for me at port 8080, like at port level, so I provide 8080 here. Container D and okay, so we have everything set up here. So toxicity is not a mandatory variable, so it's not provided, but you can go ahead and add toxicity as well if you want to give the probability. So by default, toxicity is 100%. So that basically means every request will be affected by it. So I won't change the toxicity for this demo. So we have this setup here, and what I'll do is I'll just basically just go ahead and schedule the experiment. So, okay. So Litmus will just go ahead and install the experiments and everything. So we will be seeing this come up here. So I'll also show you the helpful pod logs to see what commands we are running internally as well. So meanwhile,
No, can you summarize what you told, what you did on high level?
okay, yeah. So okay, it's just starting. The experiment is going to start. So I'll summarize it after this time. So we'll just see the experiment pod has started running. So I will take out the logs for experiment pod. Now we have the helper pod starting as well. So the helper pod has started running, and here you can see. Okay. So yeah, so what it does is started at a server, and then it basically added the IP table rule set to forward the request. Now, if I try to access Nginx, now if I try to access Nginx, it will basically return me a 500 internal server, which I was expecting, and also this body has been notified to by some HTTP body. If I had provided that modify response body as a false value, then this would not be changed. Only this 500 internal error would have changed. Now the experiment is done like the rule set has been removed. So if I try to access it again, it will basically get back to welcome. Yeah, if I had, as I said, if I had not provided the modify response body is true, then this would remain, the body would remain same, but the status code would have changed. So, yeah, so whatever time period we provide, this will basically do it for.
No, what exactly did I missed it?
Okay. Okay. So what happened is when I ran the experiment, right? So when the experiment started running, when I tried to access the service, it basically sent me a status code of 500 internal server error, which basically happened because I injected HTTP chaos, and that basically was modifying the request that was coming with the specific status code that we provided through the experiment.
So the fault that you are injecting here is you're changing the status code, right?
Yeah, correct. The status code of the response. Yeah.
Status code of what? Status code of that healthy pod, it's got down, or you're saying what exactly?
No, so the Nginx pod was running as it is. There was no like the Nginx pod didn't get down. The Nginx pod was running. The service the service was running as well. This Nginx deployment was running. Like, didn't restart it.
So the use case will be like if you wanted to inject a fault, something like regular. If we supposed to expect 200, and if we expect if we get 400, for example, and then if we have to get some alert or something, then this experiment would help to check if you're getting the alert and something like that.
No, but
Yes,
200 you will get always 200, right? Response.
No, you
No,
won't.
no.
Like,
Yeah, so that is what they are
Yeah.
changing here.
Changing
So
of what?
if you wanted to try, changing the response. See that Nginx pod supposed to give us 200, and now after the injection, it will give not 200, it will give 400 or some other response, right? Now we can check if our OE is responding to it and giving us throwing us alert and those
No, see,
kind of
my Nginx pod is already up and running. It should be 200, but it is giving 400.
Yes, correct.
Correct. I think what they're trying to do is instead of touching your target platform, right? All they're touching is the routing to the targets. They just like a symbolic link, yeah. Just pointing the symbolic link to a different service, which is giving that particular response back.
Yeah. So one
Then
thing.
actually I'm not monitoring my health of the pod, right? It is I'm getting the response from somewhere else.
So let me just clarify a few things. So like we are not sending the request from, like we are not mocking the service you are running. What we are doing is we are passing the request through a proxy server, which basically modifies the request. So every processing that has to be done at your service level, it will be done as it is. But the response that your like the user or the service A, which is accessing the service, right? So let me just put this up here. So the service A is calling suppose service B, right? So anyone
Go to the diagram. The diagram should explain to him who are asking. I think he's confused. The thing is, service A talking to service B, and in between they are introducing a proxy. And the proxy, you can change your HTTP response body, code, whatever. And when that happens, we want to understand how the service A responds to it, right? These are the typical chaos scenarios that could happen anywhere in the world. We are talking about a distributed integrated systems, right? So that's the objective of this.
Yes, correct. So
does that clarify?
Yeah.
I think
So,
we're asking that question.
Yeah, so you mean to say like my service A is giving proper response, but my API gateway or something.
No. Read the diagram properly, sir. Service B, think service A talking to service B. Service B is down for whatever reasons. Service B is not responding 200. It is providing you 500, right? In that scenario, you want to understand how resilient service A is, how is recovering from that error. That's what we are trying to do here. Okay.
No, but see,
and your whatever the gentleman talking about earlier, alerting and all, that should show up on service A. Service A should alert that, hey, I am supposed to receive 200 from service B, but I received 500. Is my alerting system set up properly, right? Or how is my application is handling that code or the error, right?
Okay,
It's
so
all about the resiliency, right?
yeah,
Think
it's
about from the
resiliency, but they should go and get the response from the actual pod, right? Not from the some mocking service, right?
Yes, so that is why what I was clarifying. So this we are not mocking your we are not mocking service B here. We are already forwarding the request through this proxy server here. So this proxy server will only modify the response as you want to. So suppose if I modify the status code, then it will only modify the status code. But whatever processing that service B is doing, it will do as it is. So there won't be any change. So supposedly service B, whenever service B request like receiving any request and it is processing something, right? It will do that processing or anything that is happening, but whatever changes you are making to the request or response, that will only be changed. So it is just going through, it is just getting forwarded through the proxy server. It is we are not mocking a service B. So any request that is coming, it will go through the proxy server to service B and then like come back and get a response to it. It won't be like it will go to proxy server and then just go back. So we are not mocking it. We are like since our proxy server, so every request will go through the proxy server and then we can modify as we want. This is actually to check whether like whenever service B is not responding as per the needs, all the services that are talking to it are working properly, or are they showing up like are they alerting you, or are they able to handle these errors that comes in with the API response?
Okay. So can I get the
Yeah,
documentation link?
Sorry.
yeah. Also, I'm thinking of like this could probably help us check if the circuit breakers are working fine and things like that, right? So that's also one of the classic use cases I can think of.
I couldn't hear your voice properly. Can you?
No,
No,
no.
I
With
was
this example, I can also check if my circuit breakers are working fine, right?
Yeah, your service B is working fine. Yes, correct. So, like service B in itself won't be affected. We are not deleting or restarting the pod. We are not making any changes to the service, like changing the service or stopping the service or stopping the pod or anything. So, service B with the microservice, it will be continuing its function properly. There won't be any thing happening to service B. What on the only change is at the application level is only at the HTTP layer. So only the modification will happen to the request response. The modification, like there is no modification happening at the service or at your application, inside your application, or the pod getting restarted or something like that.
Akshay, as request is also going through the proxy HTTP, right? Do we have an option to update the request as well, so that we can give a false request to the service B and check if service B works fine or not?
Yes, so currently with HTTP modify header, you can do that. So with modify header, you can provide the mode as response or request. So if you provide the request, then the header request will be changed. With body, it is not supported right now. Like with body, you can right now only affect the response body that is coming from the service. But I guess in future, you will have support for modifying the request body as well.
And how does the SSL handshake works here? Because we are breaking the request in the proxy itself, right? So does the SSL handshake happen there?
Okay, so like one thing is there, like this proxy server is running inside the pod where service B is running as well. So like as well as like the request is just being forwarded, we are not making any changes to the protocol or anything. So whatever like check, like whatever security or whatever TSL or something you have, it will basically be forwarded. But yes, like there right now there is no support to provide a SSL certificate or something explicitly to this service right now. But this is something that like is in the thought process.
Okay, so we are supporting the HTTPS protocols as well. Right now, it is working fine.
Yes, so it should work fine. Right now, there is like we haven't tested it very like thoroughly for HTTPS protocols as well. but like at theoretical level, it should work fine with HTTPS as well. But this is something like a proper support for HTTPS will become.
Sure. Thank you, Akshay.
Work for all container runtime engines. Yeah, so this is like independent of engine, so you can provide any engines you want to. This it's sort of like whatever we are doing is not dependent on the container runtime engines.
Do you have any plans to I mean, one good use case would be to exhaust the number of HTTP connections on a particular port, like to have a increased number of connections on particular HTTP port of service B. So would that also be supported?
I couldn't get your question. Can you speak up a bit?
Like so for now, the experiment that you are having part of HTTP experiment. So one good use case would be to exhaust the HTTP port with high number of high number of HTTP connections. For example, if my service B is hosting any HTTP application, so one good experiment would be to have a large number of HTTP connections on that particular port just to see the toleration limit of my service.
Okay, so this is basically having a lot of requests sent to, or having a lot of basically setting up a lot of requests at the service B level, right? So, yes. So this would, I guess, come in the category of load generator experiments, where we are basically trying to generate a specific amount of load to the service to process out. I guess you're talking in the sense of having denial of service attacks, right?
Yes.
Correct. So in that regard, it will, I guess it will come in better in the criteria for load generation experiment. We are trying to send multiple requests using load generation service, and to actually simulate a denial of service attack. We don't have any thought process for having this kind of things inside HTTP chaos, but
Okay. I think I got the answer. Yeah, that's fair enough.
Yes. Okay, thank you everyone. If you have any more questions, you can drop them in the Litmus Slack channel as well. We'll be answering there as well about this experiment, and you can go ahead and try it out for your use case scenario. So thank you for joining.
All right, folks. Thanks a lot, Akash, once again, and thanks a lot, everyone, for an amazing discussion and some good questions. I think a lot of people are interested in chaos engineering once again, as we know. And feel free to join the Slack channel. As I mentioned, I've shared the link to the Slack, so you can ask your follow-up questions there. And thanks a lot once again for being a part of this community, and see you once again next month, the last Thursday. Same time, we have our Chaos Engineering meetups, and we'll be covering some more exciting content once again about chaos engineering. And feel free to reach out to me if you have any questions or doubts. Once again, you can connect with any of us on LinkedIn and ask your questions as well. So once again, thank you so much for joining in, and hope you have a good day, a good rest of the day and rest of the week ahead. Thank you so much.
Thank you, guys. Bye-bye.
Thank you.